So we're going to open up the Heusinkveld smart control software. As I said before, it's just a zip file that you download from the website and just an executable that you open up. No need to install any drivers. So what we have here is a pretty straightforward interface. It looks quite complex at face value, but it's very simple when you break it down into its components. So we've got an input for clutch, an input for brake, an input for throttle, and a whole bunch of adjustments and things that we can do around there. If we click on the little burger menu here, we also have the ability to save the active profile to your hard drive. We can load a profile from the hard drive as well. So if you want to have separate profiles for different cars or different sims, you can load those in. If you've got a mate that's put together a really great profile, you can get him to send that across to you, or send your profile to a mate, to a league teammate or something like that as well. All kinds of things that you can do here. We load the profile and then we can flash it to the EEPROM on the pedals. Simple as that. Now, if we go back to the Ultimate tab here, we've got a couple of buttons along the bottom here. So load profile from pedal EEPROM, that is going to pull in the settings that are current on the actual pedal box itself. Remembering again that the settings are saved to the control module. You don't have to have the software running in order for these profiles to have effect. So we've also got the ability to reset to default. And then once we've made all the changes that we want, we click on Save Active Profile to Pedal EEPROM. That flashes those settings to the pedal box, and then they'll work every single time without the need to open up the software. So let's go across to the Calibration tab now. Remembering that we don't need to calibrate the pedals if we are going to run them exactly as they come from factory. They are factory calibrated, but if you are going to go through and make any little fine-tuning adjustments, you will need to come back in here and calibrate them. And I would recommend, you know, at least experimenting with settings, because these do have such a massive amount of adjustment available that I think you'd probably be missing out. Even though I did end up going back to pretty much those factory settings, a lot of settings when it comes to pedals are subjective. Different people are going to like different things, so it is worth taking the time to understand how all of these adjustments work and exactly how to get the most out of these for your particular driving style, as well as the types of cars that you're driving. So let's go in and start the calibration process now. It's just basically a wizard that takes us through everything we need to do. So we can see that all three pedals are functioning and they're all being detected correctly. We're going to click on Start Calibration. Select the pedals for calibration. So say, for example, you didn't make any adjustments to the throttle or clutch, you just wanted to recalibrate the brake, you would deselect those two and just calibrate the brake. But we're going to go through and do all three. So click Next Step. Make sure all pedals are in their rest position. So feet off the pedals entirely. Going to click on Next Step. And you'll notice there that the signals aren't bouncing around at all, which is a good sign. So we're going to click on Next Step. Push the throttle pedal all the way down. Now we are going to actually push them all the way down because we do have a dead zone adjustment a little bit later on. So we're going to genuinely push it all the way down. Next step, press the brake pedal with the desired maximum force. So I'm going to push that to the maximum amount of force that I ever want to have to put in when I'm braking. So I'm not going to push it all the way to the bottom. About there, about my threshold point there is normally where I want to have about 80% braking pressure, because that's the threshold of locking up for most cars that don't have ABS. And I'm going to push a little bit harder. And that's where I want my 100% point to be, about 70 kilograms of force, as we can see there. And then we're going to click Next Step while we're still pushing down on it. A little bit hard to do. There we go. Okay, and calibrate clutch, same as the throttle. We're just going to push it all the way down and then release it again and click on Next Step. So now we can quickly just make sure that everything's functioning correctly. That looks good. That looks good. We can see there the maximum force is the top of that blue line. So 72 kilos it ended up being. And then our clutch up to the top as well. So we can save that calibration. And there we go. We should see now our throttle should go all the way to 100%, return to 0. Our clutch should do the same. And our brake should reach that 100% mark at that arbitrary force, which we set as well, which it is. So that is all good. That is how you calibrate. So let's go across to profile now and have a look at some of these fine-tuning adjustments. So let's start off with the throttle pedal. We can see the bar on the left is our raw data, and we can see the dead zone on the top and the bottom there, which is marked as DZ. And then our output, which is what actually goes into the sim, or what Windows is detecting, on the right. Now you'll notice just here we have a top dead zone and a bottom dead zone of 5%, which are the default settings. And we can see that represented on the bar here as well. So if we increase that, you can see that dead zone increases, and likewise on the bottom. So let's set that back to 5% for now. So what that's doing, and you can see it represented quite clearly in the graph, is as I push that pedal down just a little bit there, you can see in the raw data, it's detecting a reading, but the output in terms of what the actual sim is seeing is still at 0%. So that's what that dead zone is doing. So once we push past that threshold, that's when we start to get a reading. So if you've got a heavy foot, you like to kind of rest your foot on the throttle a little bit, or maybe you're finding you've got a little bit of zone in there where it's not quite as sensitive as you want it to be, you can fine tune and adjust the dead zone. And the top dead zone is basically the opposite of this. So you might find when you look at the throttle input inside the actual game, you might not quite be reaching 100% throttle sometimes. Maybe you're getting a little bit lazy with your throttle input, or maybe the calibration might have slipped a little bit over time. So what we can do here is we can add a little bit of dead zone to account for that. So represented graphically, we can see the output as far as what the sim's actually seeing reaches 100% just before we reach that 100% threshold for physical pedal input. So you can see I can actually push that down a little bit more before it reaches the real 100%. So if I wanted to increase that a little bit more dead zone, you can see now I'm reaching 100% throttle at about 90% pedal deflection. So it really just depends on what you want. But for me, 5% dead zone is about right. And if we have a look at the clutch just quickly as well, we can see that operates in exactly the same manner. So no difference there between the clutch and the throttle. So then in addition to that, and this is probably the call out feature of smart control software, is the ability to set a non-linear curve for all three of our pedals. So let's use the throttle as an example again, because this is again where I think most people are going to find it the most useful. So at the moment we have linear selected, which means that our physical input is matched one-to-one with the output that the game sees. So for example, if we push to 50%, we should see the output is pretty much 50% as well. Now you can see a small discrepancy between the input and the output here. That is simply due to the dead zone that we have at the top and bottom. But we can see here on the graph, it's a completely linear input. Now, if we were to set that to an S curve, for example, so we go S shape, what you can see now is I'm having to push my pedal down physically, remembering that this is our raw data here on the left, a lot further to get the same amount up to a point. And then what we'll find is when we get to 30% input, it's suddenly going to accelerate. And you can see here the representation between, or the relationship between the left and the right. So now it's actually overtaken the physical input. So what we're getting here is effectively about a 20% increase in physical input for a 40% increase in actual output. So again, depending on the type of car that you're driving, maybe the weather conditions as well, this kind of a throttle input can be quite useful. Say for example, in wet conditions, you might want to have a slightly less sensitive throttle pedal at the initial onset. So as you're first putting the pedal down out of the corner, just to stop you from getting that wheel spin, but then you want to power away once you've started to get a bit of grip in those tires. So that can work really well for those kinds of scenarios. So another example that we might use in wet conditions is slow start. So again, you can see here a nice tapered initial pedal. So we actually have to push down to about 40% to get 25 to 30% input. And then as we go up, it starts to catch up. So again, you can imagine you're coming out of a corner, you're applying the throttle, you want to have it nice and smooth to begin with so you don't get that wheel spin. And then once you're underway, you can get the power down, and it can make a genuine difference depending on, again, the car that you're driving, the sim that you're driving, and the weather conditions. There's a lot of variables, and a lot of this does come down to subjectivity as well, but you know, it can help, and it's definitely a useful feature. Now on the flip side, if we're driving an underpowered car, so something like a Skip Barber or an MX-5 for example, we might actually want that pedal to be a little bit more responsive. So what we can do in that case is the opposite. We can go slow end, and we can see now that's actually a little bit more sensitive at the start. So we can see as I put the pedal down, my actual output is a little bit higher than my input. And then as we get to the top, it'll even out again. So again, that's just going to help us get the power down a little bit quicker out of the turn for the same amount of throttle input. And where I found this genuinely useful has been just in kind of maintaining my muscle memory without having to adapt my physical inputs on my throttle pedal to suit different driving styles, different cars, different weather conditions, and so forth. Now we do of course also have the ability to customize this. So if we start moving these sliders, we can see it jumps across to custom. So as soon as we make an adjustment, it changes to custom. And then we have 6 different data points here, 1, 2, 3, 4, 5, 6, which we can adjust. So say you might want to start the throttle out a little bit more sensitive. So start from here, for example, and you can see as soon as I put the pedal down now at all, so as soon as it detects any reading, it's going to jump straight to 25% throttle input. Don't really understand why anybody would want to do that, but you get the idea here. So for example, we might want to make it a lot more sensitive at the start, and then taper off really dramatically at the end. So say we've got a really, really underpowered car, and we can see now 30% throttle input is represented by 60% output. So yeah, I think you guys get the idea here. You can pretty much just adjust this to suit whatever it is that you're doing, whatever your driving style is. And yeah, Simple as that. So let's set that back to linear for now. So we can see here that our adjustments for the brake and clutch are identical, but obviously the way we actually fine tune those is going to be pretty different from what we do for a throttle, because obviously the purpose is different. So again, if we refer to the manual, we've got a really nice little indicator of what we might do here for a clutch to adjust for an optimal bite point. So again, assuming that you have quite a defined bite point in your adjustment, what you might end up doing is setting this to custom, and then having, you know, quite a steep curve, sorry, not there, but here. So it's quite a steep curve to begin with, and then having something that's quite flat, and then goes to 100%. And you would just basically adjust that flat point to be where the bite point is on the clutch, so it's gonna obviously vary depending on the car. And with a bite point set to say 60%, like what we have here, and again, you would adjust this depending on the car that you were driving. If we have a look at our graphical representation, you can see anywhere I have my pedal physically between 40% and 80, it's always outputting that 60%. So what that ultimately boils down to is that I'm able to have my clutch anywhere within that range and still have that optimum bite point set. So you can see how that is useful for a clutch. Now, if we move across to the brake, then, you know, obviously that's going to be a little bit different again. Now, this is really going to be ultimately a subjective thing. Different people are going to like a different kind of feel here. Personally, I generally do leave this on linear. I'm not going to lie to you guys. But for some cars, like say the Porsche Cup car, for example, which is what we're actually going to be using for our driving test in just a moment, that car is particularly sensitive. And, you know, the threshold between optimum braking and locking up is very, very small. So say a car like that, we know that our optimal braking is somewhere around the sort of 80% mark. And as soon as we push past that, we're going to start locking up. So what we might do for a car like that, for example, is go custom and then have a bit of a flatter point just here. And what that'll allow us to do is kind of brake to that threshold. So we're here, but then if we accidentally push a little bit harder, we're not going to just suddenly lock up and, you know, go sliding off into oblivion. Just gives us that little bit of dead zone there almost, where we can be a little bit more precise, and it just allows us to modulate around that optimum braking point with a little bit more precision. But again, this is going to be a purely subjective thing and very much dependent on things like track conditions, weather, the car that you're driving, the sim that you're driving in. So there really isn't a one-size-fits-all thing here, which is why it's great that we can save those profiles. So I'm going to set that back to linear for now. And just having a quick look at our brake force adjustment here as well, because you can see that's a little bit different to what we have for our clutch and throttle. So remembering again that the brake input and the maximum that we have here is, I guess, an arbitrary value as opposed to what we would want to optimize our clutch and our throttle. So we can see here, as we calibrated before, our maximum force is 71 kilos, remembering that we can put this up all the way to 140 kilograms if you wish to do so. So effectively, you can push on this brake twice as hard as what I am. And that just goes to show the wide variety of different people that this brake is suited to. I'm not the weakest person in the world, but I'm definitely not the strongest person in the world. And 70 kilograms of force is more than enough for me to feel comfortable and be able to modulate my braking pressure. I can't imagine putting 140 kilograms of force on here, to be honest, with the strength of my legs. But you can adjust and increase that if you wish to do so. We've got the force applied by user displayed here in real time as well, so that's quite interesting. I don't know where you would actually use that in terms of, you know, it being valuable data, but it is quite interesting to see how much force you're putting in. It's particularly at the dead zone there, it feels like I'm doing nothing, but I'm still putting 4 kilograms of force in there. So yeah, interesting. We have a rubber stiffness adjustment. Now, I'm not 100% clear on exactly what this does, because it doesn't appear to have any influence on the signal at all and how it responds, but I've got the softer springs in there, so I'm gonna set it to soft. I'll see if I can get some clarification around that and put it down in the comments, or maybe some of you guys might know and can comment on it for us. Now, bottom dead zone. This is a very important adjustment, particularly for me, because I do have a habit of resting my foot on the brake pedal, as I'm sure a lot of you guys do as well. And I do find that sometimes I'm putting just a little bit too much force on there, and I'm actually braking a little bit in the game without realizing it, and that is obviously costing me time around a lap. So what we can do here is increase our dead zone, and I'm just gonna sort of simulate how I would drive normally. So I'd normally probably have my foot about there if I was resting it on the pedal, and you can see that is actually braking just a little bit. So I'm gonna increase my dead zone just a couple of notches. That should be 8% there. That should give me enough. And again, you kind of do adjust for this, you know, as you learn to drive with new pedals. But, you know, working around any bad habits that you might have and kind of trying to train yourself out of them is always a valuable thing. So these kinds of settings do help you do that. Now, remember what we talked about earlier with the metal spring and how it simulates the initial movement in a brake pedal before the pads actually interface with the rotor. If you want to, you can also adjust this to simulate that a little bit more clearly as well. So you can see here, as I'm pushing that pedal in, and I'm just going to kind of stick my head down there so I can see myself, about there is the point where that spring is kind of fully compressed and the rubber springs start to compress a little bit more. So if I was wanting to really accurately represent, you know, driving a street car, for example, I might actually end up adding a little bit more dead zone there, just so that initial little bit of bite in the pedal before the pads are actually interfacing with the rotor is simulated a little bit more accurately. So again, it's purely subjective, and it is going to purely depend on the type of car that you're driving. So as I said earlier, there really isn't a one size fits all when it comes to these settings. It really is going to be a case of getting in there and fine tuning and adjusting things, again, depending on your driving style, the car that you're driving, the sim that you're driving, and so forth. But I think the really valuable thing here is two things. The fact that you can make all of these adjustments, it just makes these pedals so versatile, and then load them depending on what you're doing as well. So really, really versatile set of pedals. But anyway, I think that pretty much covers everything we need to in terms of smart control. So let's get in. I just want to quickly show you how to calibrate in iRacing as well, because that is a little bit different, and then we'll get into our driving tests. So just a quick word on iRacing calibration too. Those who are familiar will know you have to calibrate your wheel and pedals actually inside iRacing, and that calibration kind of sits separate and outside, or operates on top of the calibration that you have inside Windows and any other software that's operating in the background. So we're going to click on pedals. We're going to push our throttle all the way down until we get that 4095 reading down at the bottom, which represents our maximum in 12-bit resolution. And you can see, even if I push down harder on the pedal, it's not going to go past that 4095, because that's the hard limit as set in the profile, which we flash to the EEPROM on the controller. So we don't need to worry about under calibrating for a dead zone or anything too, because that's all handled by the profile too. So we've got our maximum, our minimum, click done. Exactly the same thing for our brake as well. So we push to the maximum, release to the minimum, click done. Same deal with the clutch, maximum, minimum, done, and done. And now we are fully calibrated. Now this is something that I've found particularly beneficial, because quite often when I'm changing hardware, so say for example, I'm changing between different wheelbases to do testing, you end up having to recalibrate everything, including your pedals. And if you're manually calibrating your pedals in iRacing, because you're having to set that mechanical limit for the brake pedal in particular, it can be really hard to get that exactly the same every single time. What this means is that the calibration process in iRacing is always going to be identical, as long as our smart control calibration is the same. So what it means is I'm going to have a consistent pedal feel all the time in iRacing, even if I need to recalibrate. And I have found in the past, I've had, you know, the perfect calibration. I've done lap after lap after lap, absolutely optimizing my driving, and then had to go and change something, and I've never been able to quite get it exactly the same as I had it previously. So if you are somebody that finds yourself having to recalibrate in iRacing quite often, this is definitely going to be beneficial for you. Then once our calibration is finished, we just want to also make sure our brake force factor is set to 0. That's going to stop iRacing from putting any additional filters on top of the settings that we've put inside our profile in Smart Control.